Welcome back, everyone. We now begin the second panel of the launch event for the Ardent Colonies Conscious, Collective Minds and Philosophical Implications, published by FIP Press. My name is Luis, and I co-edit with Anderson Fonseca. We were also involved in the translation of the two texts that form the basis of the presentations in this session. The translation process offers us the opportunity to examine these outstanding contributions in greater depth, and I strongly encourage you to read them in full if you have not done it yet. We thank the authors and the Journal of Consciousness Studies and the journal Avant for granting permission to publish these two presentations. And our first presentation is by Sophie Nelson and Eric Schwitzgebel. Their talk is titled Introspection in Group Minds, Disunities of Consciousness and Indiscrete Persons. Let me briefly introduce the authors. Sophie Nelson is a PhD student in the New York University. She has a bachelor's degree in philosophy and psychology from Aberdeen College. She has been exploring questions related to shared phenomenal experience, the unity of consciousness, and the accountability of minds. Eric Schwitzgebel is professor of philosophy at the University of California. He has a PhD in philosophy from the University of California. In philosophy of mind, his main research themes are introspection, moral psychology, and belief. Sophie, the floor is yours.
Thank you so much for inviting me to this event. I'm so excited to be presenting here. Okay, so let's get started. So ordinarily, we assume that minds are discrete and countable entities. We also assume that persons are discrete and countable entities. And furthermore, we assume that introspection and communication are just two categorically distinct processes. There aren't any mental processes that fall somewhere in the middle. And normally, if you ask me how many people were in the room and I said between 2 and 3 or 2 3/4, you'd just think I was joking. These are things we just don't usually question. But we are going to argue in our presentation that these assumptions are possibly wrong. There might be indeterminate or maybe intermediate cases of minds and persons, although we won't focus so much on the determinate intermediate cases. And in addition, introspection and communication might exist on a continuum with intermediate cases between them. So let's start by thinking about a very strange science fiction type of case that we hope will make our thesis somewhat more intuitive. So we're going to base it on the complex sentient worship in the book Ancillary Justice, which was published by Anne Leckie. So in this book, there's a sophisticated computer orbiting a planet. And in addition, the surface of the planet has platoons of 20 humanoid robots each. The humanoid robots are in constant communication through satellites. And let's just call the orbiting computer Aleph, and let's call each robot by its platoon letter and member number. So we'll have like A1 through AJ. So in platoon A, or so like A1 would be the first member of platoon A, and AJ would be the last member of platoon B, and B1 and BJ would be the same anyway. And it's also worth just noting before we begin to further think about this case, that for now, we're just going to assume first that it's possible in principle for AI systems to be conscious. This may not be the case. It might turn out to be that biologicism is true, and so consciousness is a property that can only be instantiated in biological organisms. It also might end up being the case that consciousness is a functional property, but maybe one that can only be implemented in biological systems and not AI systems. But we're going to put this possibility aside. We're also just going to take sort of a broadly functionalist approach, according to which functional and informational processes are what matter for whether a system is conscious. We're not going to commit ourselves to a specific metaphysical view about the relationship between consciousness and the physical. So we're not going to commit ourselves, I guess, here to metaphysical functionalism. But we do want to say that that whether an AI system can be conscious is largely determined by whether it has the right type of functional processes. Okay, so let's consider some ways that this system might be laid out, and then how many minds might result. So suppose the ancillary structures, cognitive processing, is distributed between Aleph, the central computer, and the robots. But it's nonetheless as tightly integrated as the processing within human brains. In this case, we would plausibly think that it constitutes one mind distributed across several locations. On the other hand, if the ancillary structure's cognitive processing takes place primarily within Aleph, then it plausibly constitutes one centralized mind with 200 robotic appendages. So maybe the robots are more like arms or legs. But then if the ancillary structure's cognitive processing is pretty distributed throughout Aleph and the robots and really loosely integrated with very little connectivity, then the system might actually constitute 201 minds. And if the cognitive processing mainly transpires in the robots and Aleph is really just kind of a relay system, then the ancillary system might just be 200 minds distributed across the planet's surface. Maybe each of the robots has a mind, but not Aleph itself. But everything I've described so far is a limit case. What if actually the cognitive processing is partly in Aleph and partly in the robots, such that Aleph and the robots are more closely integrated with one another than, say you or I, but less closely integrated than, let's say, the two hemispheres of my brain? What if the communication between them is swift and thick and it's direct, but it's just not quite swift and thick and direct enough to resemble anything like the kind of minds that we're used to? The intuition that I have and that I think and that Eric shares and that I think a lot of people share when presented with this case is that the ancillary system would actually possess an indeterminate number of minds, somewhere between 1 and 201. So if we were to try, and if God were to try and count up how many minds the ancillary system had, God wouldn't end up with a determinate whole number. I think the somewhat more plausible case is that, how many minds are present is just indeterminate. But I guess it's also possible, as we discuss in a later paper, that the number of minds might also be determinate but fractional. So, it might have 72.196 minds, let's say. Seems unlikely, but who knows? Anyway, so such a system might be pretty difficult to imagine. So let's just take some time to flesh out more carefully just how it might operate in hopes of better conceiving of its inner workings. So how might perception work? Let's consider an imaginary scenario. So maybe platoon A is examining a field of flowers, and 16 members of A are each employing their own local processing, and they initially represent the flowers as 50% blue and 50% red. And then 4 members of A, in contrast, of platoon A, initially represent the same collection of flowers as 70% blue and 30% red. And then Aleph, the central computer, receives the conflicting signals. Maybe Aleph employs sort of a winner-takes-all procedure and just represents the flowers as 50% blue, like the first members of A. Maybe Aleph employs a weighted proportion procedure. Maybe Aleph employs credences. There are a ton of other alternatives. It's, and then it's possible that, and then we can also conceive of all sorts of possibilities for how Aleph's representation that it forms then might be related to each platoon. So maybe platoons B through J receive this as new information, having never seen the field of flowers, and then 16 members of A receive Aleph's signal as confirming their representations, and then the other 4 receive Aleph's signal as disconfirmatory, and then they update their local representations. And so there are just all sorts of complicated things that might happen here. What about memory? So let's consider another scenario. So maybe for fast motor action, each robot will have substantial autonomy for basic procedural memories, for example, like how to open jars, and short-term or iconic memory. Maybe they'll each have substantial autonomy for remembering the exact position of the flowers as they sway in the wind. But then perhaps more complex skills would require more complex interactions with Aleph, including longer feedback loops and top-down guidance. Maybe coordinated procedural memories would also would also be the same, where they require a lot of top-down processing. Semantic and episodic memories might invite sort of the same diversity of conflict resolution procedures as we discussed with the case of perception, if the robots disagree. And then we can consider external memories. They might be stored in records in a cabin to which at least one robot has reliable access, or they could be written on the surfaces of the robot's bodies or inside each of the robot's brains, or they could be simply located in Aleph. So again, there are just a ton of possibilities, and different possibilities lend themselves to different intuitions about how many minds there are and whether, there might be an indeterminate number. How might action work? Let's imagine that the same local processes in robot A1 form an action plan, so pick flower 1, and then at the same time an action plan arrives from Aleph, pick flower 2. Instead of assuming that the local plan always wins over the Aleph plan or vice versa, maybe each action plan will carry a strength signal. So if pick flower 1 has strength 3.4 and pick flower 2 has strength 2.6, then pick flower 1 will win regardless of where it has originated. More complex models might compromise among ranked action plans. Action selection might be automatic, or it might be non-conscious, or it might involve conscious ambivalence, or it might involve some kind of deliberation between the different robots or between the robots or Aleph. And I mean, once again, just like in the case of memory and in the case of perception, there are a million ways we could imagine this. So in light of all of this, let's consider another idea that seems sort of intuitive. So again, ordinarily we think of introspection as a process by which one comes to represent one's own mind, and communication as a process by which one comes to represent another person's mind. But if it's indeterminate whether the robots and Aleph are distinct minds or whether they're part of the same mind, then when information is shared between them, it might also be correspondingly indeterminate whether the sharing of information constitutes introspection, within the same mind, or communication between multiple minds. Before we move on, let's just actually take a moment to think about why even these questions are important. Why should we care exactly how many minds Aleph or the ancillary mind has, whether that's 1 or 200 or 201 or 72.4569 or something metaphysically indeterminate? I mean, the answer really is knowing the number of minds, and also in particular the number of persons present in the ancillary system, is really essential if we're going to ask if we're going to be able to answer certain kinds of morally relevant questions. So let's say we want to know how many people will die if the ancillary mind is destroyed. If the ancillary mind makes a promise, how many people will be bound to it? If the robot A3 throws herself in a volcano after receiving instructions from Aleph, has a person committed suicide at the command of another, or is the situation more like a person sacrificing a limb? If the ancillary mind wants political participation, how many votes should it get? How many persons is it? Is it one person? Should it get 1 vote or 200? If it adopts a child, how many parents can the child be said to have? If the ancillary mind enters a romantic relationship with somebody, is that person in a monogamous relationship, or are they in like a massively polyamorous one? If let's say one of the robots, G9, tells me that I'm her friend, how much of the system am I justified in taking myself to be friends with? Am I friends with just G9? And can I not trust the rest of the system to have any kind of friendly relationship with me? Or am I friends with the entire thing? Can I trust that Aleph is on my side too? I mean, the questions are kind of endless, and they're endlessly interesting. Why might we worry about the indeterminacy thesis? So we sort of see 3 major sources of resistance. And we call them the phase transition view, the body view, and discrete phenomenal realism. And we're going to talk the most about the last source of resistance. So according to the body view, we count persons just by counting bodies. So, if there are 2 bodies in the room, there are 2 minds or persons. If there are 451 bodies in the room, then there are 451 minds or persons. We're going to set this view aside, actually, because our interest is mainly in cognitive systems, but also we think it's pretty implausible anyway, because it does seem like there are probably cases in which the number of bodies is also indeterminate. So I think the clearest example of such a case is conjoined twins. I sort of wish I put a picture on this slide because to trigger this intuition, but oh well. So yeah. Then there's the phase transition view. So the phase transition view observes that sometimes actually sudden phase transitions do just disrupt sharp continua. So think about water. Water cools and it doesn't change that much. It just gets colder. And then suddenly at 32 degrees Fahrenheit or 0 degrees Celsius, it becomes ice. or think about a beam that strains under each increasing weight. As you, let's say you drop marbles on it, and with each marble it strains just a little bit more, and it doesn't change its appearance much or its behavior, and it just bends a teeny tiny bit more in a way that's almost imperceptible. And then suddenly you add 1 more gram, and then it just snaps, it collapses. So according to the phase transition view, something similar happens with the system at hand. You integrate it slowly, a bit at a time, and then all of a sudden, with some tiny bit more integration, the whole thing changes radically. The processes that constitute perception and memory and action and introspection all of a sudden shift from following one pattern, sort of like the 201 person pattern, to following a very different pattern, or the 1 person pattern. So with some minor physical change, you get a radical metaphysical change. So, I mean, we can't strictly rule this view out. We have no way of proving that this isn't the case, but there just seems to be no good reason to hold this position. You know, why think that something so strange occurs? And I mean, and the other worry is just phase transitions, when we actually look deeper into nature, seem pretty rare among macroscopic entities. So, I mean, it seems to us, from our perspective, that the water doesn't change much at all, and then all of a sudden there's a big shift that happens at 32 degrees, and you know, and then it becomes a solid. Or it doesn't seem to us like much is happening to the beam until that very last marble is dropped on top of it. But if you were a scientist and you were looking at any of these cases under a microscope, you actually would see massive changes occurring at the molecular level. And so the sudden phase transition wouldn't really seem like as much of a sudden phase transition as we ordinarily take it to be. And really, I mean, I think there's some research suggesting that true sudden phase transitions in the physical world only happen at the quantum level. And so unless there was some kind of connection between the quantum level and consciousness or something like that, it doesn't seem like this is a good candidate. And then finally, we have discrete phenomenal realism. So, I mean, strictly speaking, in a way, discrete phenomenal realism is a form of the phase transition view. It's a specific form. So, according to discrete phenomenal realism, atop all of the representational and cognitive processes, there are just some simple phenomenal facts that determine personhood or consciousness or subjectivity or mindedness. And we are inclined to think that this is kind of the most plausible version of discrete phenomenal realism. So the view draws its plausibility from the attractiveness of treating phenomenality, or what its likeness or phenomenal consciousness, as discrete without indeterminate or borderline cases. So for some background, a lot of people have the intuition that you know, you're either determinately conscious or you're determinately unconscious. There can't be anything in between. And the reason why people tend to think this is because it's hard to conceive of an indeterminately conscious state. You can conceive of you know, you can conceive of yourself being in a very in a conscious state that isn't very vivid, but it's hard to, but I mean, even if you imagine just the faintest experience in the world, it seems like you're still imagining something that's determinately conscious. You're just not imagining something that has very interesting content or very complex content, or very or that's represented in a very vivid manner. Anyway, so so the thought here is maybe there's, you know, either there's something it's like to be robot A1 and A2 and A3 and so on, or there's nothing it's like to be those systems individually, and instead there's something it's like to be the ancillary system as a whole. And in the former case, there are at least 200 subjective centers of experience, and in the latter case, there's just 1 subjective center of experience. I have sort of a diagram here that I've made to demonstrate how discrete phenomenal realism is supposed to work. So we can imagine the yellow-green circle as robot A1, and the purple circle as robot A2, and the teal circle as robot A3. So there's something it's like to be one, there's something it's like to be the other, there's determinately something it's like to be the third, and it's not like you can have an indeterminate number of phenomenal spheres or centers or loci of experience. So discrete phenomenal realism fits nicely with a classic account of the unity of consciousness as well, according to which any given experiences A and B are unified if there's something it's like to have A and B together. The diagram will also help with envisioning this. So imagine one locus of consciousness in which experiential states alpha, beta, gamma, and delta occur, such that each is introspectable by the first subject. The second subject has experiences epsilon, zeta, eta, theta together. The third subject has experiences iota, kappa, lambda, mu. Count up. We use Greek letters here. Count up the introspective subjects. Or the loci of mutual phenomenal co-occurrence, and then that's your number of minds, or that's your number of persons, and then the result is always going to be a whole number. That's the thought. So one big problem with discrete, all right, so let's just talk about what are the problems with discrete phenomenal realism. So one that's pretty clear is for it to work, discrete phenomenal realism has to posit sharp ontological lines on top of fuzzy continua underneath. If discrete phenomenal realists reject the phase transition view, then systems like the one we're talking about can be very similar to each other in all representational and informational and behavioral respects, but radically different in their consciousness. From the outside, the systems, a system right before one change happens and a system right after that one change happens will seem identical. But then from the inside, they'll seem different. And to most, this seems crazy. At no point is it like the system's consciousness suddenly splits and then it cries, I've suddenly split into 200 pieces. It seems exactly the same. And then as a result, it seems like discrete phenomenal realism seems to sort of separate consciousness from behavior in a way that doesn't seem right. So another major problem, and we'll discuss this further, is that discrete phenomenal realism arguably struggles to make sense of cases of partial experiential overlap among the robots in the case of the ancillary system. So let's imagine a case where we have robots A1 and A2 in the ancillary system sharing much of their cognitive circuitry. Let's suppose that between the two there's a box in which much, but maybe not all, of their cognitive circuitry transpires, and as a result, the robot A1 has experiences alpha, beta, and gamma, and A2 has experiences beta, gamma, and delta. So if indeterminacy concerning the number of minds is possible, then plausibly this is a case of an indeterminate number of minds. I mean, this seems like exactly the kind of case that our view is supposed to account for. But discrete phenomenal realists will have to make sense of the case in a different way. And it seems like there are a few options for how they can do that. So it seems like there are three options in particular. So their first option is to say, actually, this just can't happen. I mean, the problem here is just why? Why can't it happen? It seems kind of ad hoc for them to say that. Their second option is to accept sharing and say that in this case, we have two determinately different minds that share token identical experiences. And so we have one unity of consciousness, we have one unified conscious mind that contains alpha, beta, gamma. We have another one that contains beta, gamma, delta. They're determinately different, but they share two of their experiences in common. A problem here is that we're forced to deny that phenomenal unity is transitive. And this is different from how people usually think about phenomenal unity. So normally people will assume that if there's something it's like to experience, A and B together, and there's something it's like to experience B and C together, then there's also going to be something it's like to experience A and C together. I mean, if we took the option of sharing, there would be something that was like for the first subject to experience alpha and beta, and something it was like for subject 2 to experience beta and delta. But there wouldn't be anything that was like for anyone to experience alpha and delta together. And that, for a lot of people, is just really hard to imagine. And then finally, the discrete phenomenal realist can take the option of similarity and say that the robots would each have their own experiences. So A1's and A2's experiences would be type identical, but they wouldn't be token identical. So there would be kind of a duplication. And that's the worry with similarity. The duplication that would have to be involved just seems really unparsimonious. So let's make the case even more kind of challenging for the discrete phenomenal realist. So suppose there's a switch that can turn off experience alpha and delta for subject, or alpha for subject 1 and delta for subject 2, respectively. So before the switch is flipped, subject 1 will be experiencing alpha and beta and gamma, and subject 2 will be experiencing beta and gamma and delta. But afterwards, subject 2 or subject 1 and 2 will both only experience beta and gamma. So qualitatively, their experiences will feel, their phenomenal fields will feel completely identical. And I think, or we think, it's pretty hard for discrete phenomenal realists to make sense of the situation. So arguably they have 4 options. And we've laid them out on a chart here, which I hope is helpful. So you can see we have the situation before the switch is flipped according to similarity, and we have the situation after the switch is flipped according to sharing. And really there are 4 options. So 2 for similarity, 2 for sharing. So first, discrete phenomenal realists who accept similarity can hold that upon flipping the switch, there remain 2 minds with type identical experiences, but not token identical experiences. So the minds don't collapse. Alternatively, they can hold that upon flipping the switch, the 2 distinct minds collapse into 1. What the switch that has this slight that creates this slight phenomenal change just causes there to be only 1 mind where previously there were 2. And then meanwhile, defenders of sharing they have similar options. So they can hold they can hold that upon flipping the switch, there continue to be 2 minds, but these 2 minds just have exactly the same phenomenal experiences. They have the same token identical phenomenal experiences, not just the same type identical ones. And then after, and then alternatively, they can hold a collapse option where they think that the switch causes there to be only 1 mind where previously there were 2 as a result of the slight phenomenal change. So the main problem with the 2 collapse options is that the discrete phenomenal realists then have to allow that the tiniest phenomenal change will cause just this radical reconfiguration of the number of minds in the world. And that seems sort of crazy. We don't usually think that, like, if one experience from our phenomenal field goes away, then all of a sudden we can have, the number of minds in the world could change. That seems bizarre. But the problem with the no collapse options is that they then have to allow that distinct subjects could have qualitatively identical experiences that are grounded in the same physical processors. And this just raises a lot of ontological questions about the individuation of minds. And it might not even be coherent. If it's possible for there to be 2 distinct minds, but then each of those minds is, again, grounded in the same kind of, or associated with the same kind of physical process, and its experiences feel exactly alike, and it functions in the same way, then in what sense is it even really coherent to say that there are 2 minds present? I'm not entirely sure. So what's the upshot? Let's go back to Earth. There are, assuming that that this view is right, that there can be an indeterminate number of minds in the world, then there are kind of quite a few cases on Earth where the number of minds is plausibly indeterminate. So here are some examples. So first, consider craniophagus twins. There's this really interesting case with 2 girls named Tatiana and Krista who are connected to the head. Their thalami, so the parts of their brains that process and transmit sensory and motor information to their cerebral cortices, are connected by a thalamic bridge. And as a consequence, they appear to share certain kinds of sensory experiences. There's an anecdote that often gets told about them. So one of the girls really likes ketchup and the other one hates it, but the latter gets mad when her sister eats ketchup because she can taste it. And if you have, and in addition, if you have one of the girls close her eyes and touch her sister on the arm, or touch her on the arm or the leg, her sister can actually identify exactly where she was touched. So it seems like they can kind of feel each other's bodies. Split brain cases are other cases that are kind of clearly relevant to the question of how to individuate minds. So in the classic split brain experiments, researchers have studied people whose corpus callosums, whose corpus callosum, so the primary bundle of fibers connecting the two hemispheres, has been surgically severed. This is usually done as a means of treating severe epilepsy. And because visual information from each half of the visual field goes to the opposite hemisphere, experimenters can present different images to the left and the right visual fields while the person fixates on a central point. And the key result, basically, is that the information going onto the right hemisphere can't be verbally reported because speech is controlled by the left, but the person can still use their left hand, which is controlled by the right hemisphere, to point or draw what they saw. And then information shown to the right visual fields, controlled by the left hemisphere, can be named easily. So another case would be octopuses. So the central nervous systems of octopuses are radically different from our own. Instead of being centralized in the head, the neurons of an octopus are distributed across 8 tentacles. And when a tentacle is severed, it displays behavior that appears similar to the way it actually behaves when attached to the octopus as a whole. And as a consequence of this, some people have suggested that the consciousness of an octopus may actually be located in each of its legs. Then we have dissociative identity disorder. I'm inclined to think that this probably isn't the best example of such a case, but it's one we might consider. So in dissociative identity disorder, you have an individual who develops multiple kind of alter personalities that differ in their memories and their character and their abilities and their preferences and their patterns of awareness. And different alters are triggered by different environmental cues. Sometimes the alters will partially share memories, or they'll fuse back into one another as a result of certain types of therapy that aim to kind of reintegrate a person's cognitive system and help them address the trauma that initially caused the disorder. And it could be that the brains of people with DID host an indeterminate number of minds as well. It also could be the case that they just have a very severe type of memory disorder. And then finally, my co-author, Eric Schwitzgebel, has argued in the past that if materialism is true, the United States as a whole is probably conscious. And the thought is there's some sense in which it maintains homeostasis and it reproduces through fission and it defends itself against threats. It engages in complex cognitive processes and it's even partly composed of biological material, that is all of us. And so maybe for all we know, the entire country is a case of an indeterminate mind as well, even though that's very highly speculative. And I mean, the idea sounds crazy, but I mean, what reason in principle do we have not to accept it? It's hard to rule it out in principle. And then finally, we can also apply these ideas to the topic of the book, around which this event is centered: ant colonies. Ant colonies operate as highly organized superorganisms. The colonies are typically led by a single queen female who lays eggs, and as Luke put it in the previous talk, kind of functions as an ovary. Then we have other ants who work in close coordination to forage nutrients and to mate with the queen and to repair the colony and care for offspring. And decisions are made by the colony as a whole, which is semi-spatially unified and even kind of has a chemical nervous system. So given the extent to which ant colonies are integrated, much more so than typical human societies, one might think that ant colonies are actually cases where there might be an indeterminate number of minds as well. Maybe each ant is an individual mind, and the colony maybe the colony as a whole is indeterminate between one mind and the number of minds or the number of ants there are, or something like that. Or maybe each ant is a case of an indeterminate mind, or and the colony as a whole is determinate. I mean, the possibilities are strange and endless. So we'll just end with a simple question: what if we're more like these types of cases than we ordinarily assume? What if there's some sense in which we have an indeterminate number of minds as well? And that's it. Thank you so much for listening.
Thank you so much, Sophie. So we can start our Q&A. Anyone? Let's see. Someone raise hands? No? Anyone has a question? Sophie? João? João, are you able to speak? Or it's closed? Okay, you can speak.
Hi, people. It's me again. Everyone is listening well.
Yes.
Okay, so thank you for your talk, Sophie. It's very, very interesting. Even when you get some things on science fiction, you know. And first of all, sorry for my English. I will try my best here.
No, don't
I
be
was
sorry.
I was wondering when I saw your presentation when you talking about a dilemma for a specific view, the funny children that switch uh, then a N1 and after A2, then A1 after A2. I was thinking a thought experiment. So, for example, what I'm saying here, in the case of slipped brain, if I believe that a person that have a slipped brain have something like two selves, and I get some interrupter in this kind of brain that I turn on, then the two hemispheres connect, and I turn off, the two hemispheres don't connect anymore. In this case, uh, is do you think that we're facing the same dilemma? Because I could imagine a possible world that everyone is sleeped brains and everyone have this kind of switch in their brains. And I will put on and I put off and I put on. And in my intuition says to me that no, this is not a problem. Okay, it's metaphysical strength because this word, one bottle will duplicate selves and subtract selves again, but some it's kind of strange, but for me it's not strange at all. And I was thinking if will be strange in the case of the robots that you were saying. I was clear. Do you understand?
Yeah, thanks so much. That's a great
You're
question.
welcome.
So, okay, so if I'm understanding you correctly, it's we can imagine a world where everybody's brains are connected by switches, like we had in the thought experiment. And so you could just, you could turn one person's, or I mean, I think I'm not maybe not quite exactly understanding the structure of the case, but that's my fault, not yours. You know, so like you could, I don't wait. So actually, the more I think about this, the more I think I'm not quite clear. I understand the structure. So like, is it like we have everyone's conscious experience is connected into one kind of grand unified
No, no,
mind?
no.
Turn
Sorry,
parts of
I
it
will
off?
try. I will try again. Everyone have a slept brain, and
Okay.
every brain have a switch. Then I can turn on the switch and the two hemisphere of this brain will be connected again. And if I believe, for example, a presupposition on this case, if I believe that the case of the slept brain, this person have two selves, not only one self. In this word, I will duplicate the selves when I put the button on. And for me, it's not strange at all. And I guess that's a very similar case in your thought experiment that you were saying about switch.
Yeah. So I mean, if everyone had a split brain, I think I might want to say that everyone had an indeterminate number of minds, because it seems like if an individual split brain patients constitute cognitive systems with an indeterminate number of minds, then what reason would we have to say that a large group of split brain patients wouldn't be a large group of cognitive systems that constitute an indeterminate number of minds? I think generally, if you have one individual that possesses an intrinsic property, then if you have a group of such individuals that are identical to the initial individual, every member of that group will have the same intrinsic properties. Like if you were to, like my phone has a purple case. If you were to duplicate my phone case, then it would, exactly, then all of those cases would also be purple. So in the same way, like if you duplicate if you just have a group of split brain patients, they would probably have the same properties as individual split brain patients. I don't know if that might not make any sense, but yeah. And it's interesting that you don't share the intuition that that would be as much of a problem, even though maybe you do have the intuition with an individual split brain case. And I'm not quite sure how to convince you if you don't share the intuitions through the kinds of intuition pumping I've tried to engage in thus far. Eric, do you have any thoughts?
Yeah, I was thinking, if that were the case, and if it felt like something to split or unsplit, I mean, there's some dispute about whether in non-artificial environments people can even really notice the fact that they're split. But let's say it feels like something and you notice, and they're pretty big functional changes. Then we'd probably have to create a new language, right? So, when I'm split, there'd be Eric A and Eric B, going along, and then after I've joined back, I'll be Eric AB, right? And then we'd have to have we'd develop a new language where there are, which would person attach to Eric A and Eric B, or it attach only to Eric AB, or how would we do that? We'd invent a new category that might not map neatly onto our current category of person, right? So that I think that's a nice thought experiment for thinking about how what we think of as these discrete metaphysical fundamental categories really might be in part contingent social constructions.
I agree.
Thank you. I'm sorry for my English. I try my best.
Perfect, João. Luke, please.
Maybe jumping off Eric's last response there, I guess I should start by saying I'm 100% in agreement about moving away from the view that kind of takes a standard set of assumptions where there's a discrete number of non-overlapping minds and there can't be intermediates or blurry lines or anything. The kind of view that would take that really seriously and take that to be the deep metaphysical truth. I'm fully on board with ditching that. But I guess it seems to me that as we move away from it, there's sort of two slightly different paths, which your paper kind of runs together, because you often say indeterminate or intermediate. Indeterminate is kind of saying like, well, there's a number here, but what number is it? Who knows? It's kind of stepping back from providing detail. Intermediate, where you would say, there's 2.5 minds, or there's 3 1/4 minds, is actually providing more detail. It's a richer and more specifically worked out form of description. And I guess I'm sort of imagining two different versions of the talk, or of, I don't know, you as the authors. And then there's a switch. No, there's no switch. One would be to say, as we move away from the kind of cases we're familiar with, this whole framework of thinking is just going to break down. Right? We're going to have to come up with completely new concepts to replace the concept of a mind or a person or a subject. And it's going to be largely incomprehensible if we try to kind of translate it into current terminology. Call that, I don't know, the revolutionary. And the reformist option is to say, well, we can keep the notion of a subject, or the notion of a mind, or the notion of a person, or whatever notion we currently have, but extend it or amend it to allow for instance, 1.5 minds, or some other number like that. But it will still be able to make good sense of these situations by applying the same concepts, just in a slightly loosened or adjusted way. And I guess I'm wondering whether you, Sophie, or Eric, have thoughts on that kind of revolutionary versus reformist choice. Are we going to have to burn it all down and rebuild from the ground up, or can we preserve the conceptual framework while making modest adjustments?
Yeah. So a couple of thoughts. So first, I completely agree with you that the question of indeterminacy and the question of intermediacy are distinct. And we do try to tease those two issues apart in a later paper that we've written about this topic. Because yeah, I mean, it could in principle be the case that there are systems in the world in which the number of minds is metaphysically indeterminate, so you just kind of can't give a number, or you can't give one single number to describe the case, including a fractional number. Alternatively, it could in principle be the case that there are systems in the world where the correct thing to say about them is that there are determinately 1.4578921 minds. And those are two very different things to say about a cognitive system. And I completely agree that we kind of run those issues together in the paper. Although I think in this paper we try to focus more on the indeterminacy case than the intermediacy case, which, for what it's worth, is what we've tend to found people to be more sympathetic to when we've shared things that we've written about determinate intermediacy. People are usually like, what? How could it possibly be that you could have like a very specific fractional number of minds in the world? I don't even know how to make sense of that possibility, whereas it does seem like people are a little bit more sympathetic to indeterminacy. Eric, would you agree with that observation?
That's a fair characterization of the sociological fact, yes.
Yeah. Okay. So that. Yeah. So those are kind of the sociological facts. As for the kind of conceptual scheme we need to use to think about these issues and whether we maybe need radical restructuring. So my thoughts on this aren't fully worked out, and so this might be a little bit rambly, but kind of off the cuff. I mean, first of all, I'm inclined to think that concepts like mind and person are so sort of deeply baked into our language and our way of thinking that we're never going to be able to fully get rid of them. And maybe we would never want to fully get rid of them. Like, it doesn't matter how much cognitive science I do. It doesn't matter how much I think about philosophy of mind. It doesn't matter what kinds of empirical facts I learn about myself. I think there's a sense in which I think, like, if I'm interacting with my family, I'll always feel like I'm just interacting with minds or persons in the ordinary, everyday sense that we usually use those terms. And so I think, a complete radical transformation of our language probably isn't possible or desirable. However, with that said, I'm also inclined to think that it would be nice to precisify some of the kind of language that we use to talk about minds and persons in the philosophical sphere. So I wish that we had different terminology for discussing minds as sort of things that have bundles of experiences versus minds as bundles of experiences themselves. I sometimes wish we had different terminology for those two types of things. I wish we had different terminology for talking about minds as phenomenal subjects versus minds as cognitive systems or types of functional processes or something like that. And maybe in the future, it might be an interesting conceptual project to do some of that work and tease some of those notions apart. But I'm still not quite sure. I mean, again, my thoughts about this are sort of in an early stage of development. Eric, what are your views on this?
Yeah, so I'm inclined to think that we ultimately want something stronger than just indeterminacy, something a little more radical than that, despite people's hesitation. And I think the scalars don't work well for people to say 2.5 minds doesn't. It seems like the mathematics is going to maybe be different. You might need to use mathematics of geometry, multidimensional vector mathematics or something like that rather than scalars. But then I'm inclined to think, once you get kind of the appropriately sophisticated mathematical representation of the in-betweenness case, a non-scalar one, then you get the indeterminacy as an outcome because it's not clear how to map that case onto your determinate categories. And one analogy here, I think, would be counting bodies, right? For how radical this would be counting bodies, right? So we're great at counting vertebrate bodies. I mean, there are a few exceptions with conjoined twins, but for the most part, vertebrates come in neatly bundled packages that are easily countable. But once you get to some invertebrates like sponges and some plants like birch forests and crabgrass, right? It's not, or Bermuda grass, it's like what the boundaries are of an individual becomes much less clear, right? So if we were to, in the future, possibly live in an environment where there were lots of ancillary structures or other sorts of entities that don't fit neatly into our presuppositions about accountability of personhood and mind, then our language will seem crusty and old-fashioned and not suitable for what we're doing. It would be like trying to go out and count how many individuals there are in a sponge colony. So if we dwell among vertebrates and things don't change radically, fine, these are kind of remote metaphysical possibilities. We want to get the metaphysics correct. But if that doesn't continue to be the case, then there might have to be really radical conceptual change. I mean, conscious LLMs would be a major potential application here.
I completely agree. Like, I think it's not at all clear how we would individuate AI subjective experience, at least given our current kinds of AI.
I will be a good host and won't make the question. I will pass to João. João, if you wanna make your question.
Thank you, Luis. Thank you all. I'm sorry for the start. I have one question, but I have to speak about myself to make that the question. The phenomenal realism. I'm schizophrenic. I have schizophrenia, and I have the client board tendency to see myself in states and not as a one entity objectivity. But when I try to speak to another person about my subject experience, the person say to me that I'm on an illusion, on a constantly psychosis, and I am not a validated subject with knowledge. So I have a epistemology way, so I try to discover a epistemology way for I have for be a subject with knowledge and valid, and so my question is, how do you relate the phenomenal realism with the idea of representation and illusion? Because I was schizophrenic. In Brazilian law, I have to frequently prove that I have responsibility and autonomy about my actions. So how the phenomenal realism can help me with the notion of representation and illusion when I trying to, you understand?
Yeah. Let me think for a moment.
Because I know I have hallucinations. I know the world is not an illusion, but some things that I see, I know that doesn't exist. But the world for me is not an illusion. I know what is illusion, and I know what is the world. But people don't understand when they trying to say about it.
Yeah, so that makes sense. So I think, certainly, on our view, I mean, you're phenomenal subjective experience. You're at least one determinately, and you have a lot of very, you have a very interesting kind of experience that that many of us wouldn't be able to fully relate to, and I think it's actually hard to, and I'm not sure our view would have a ton to say about the particularities of how to make sense of your experience, or about what kind of subject you are, or what kind of autonomy you have. I think that's, I think that would be that's a very interesting thing to think about philosophically. But I think our project probably underdetermines the answers to those questions. I think all we're sort of equipped to say is just that in principle, there might be an indeterminate number of minds. Maybe you have an indeterminate number of minds. Maybe you're determinately one mind. I think we would have to get to know you better to be able to say. So those are some sort of sorry if that wasn't the most sort of articulate response. Eric, do you have any thoughts?
That's nice. That's like the art, state of art. So
Yeah, I mean, I don't know that much about schizophrenia, but I will say that one aspect of the view we've been articulating is that what matters to having a mind is that you're having experiences, you're having perception, and you're having action and memory and all that. And there are these kinds of views that require a lot more than that to count as a person, right? Where you might feel like or they might think that you don't qualify as one because you don't meet some threshold that they have, right? And we're not proposing anything like that, and I think it's much more natural to think about the minds and personhood in terms of these kinds of functions that I'm sure everybody. Now, if there are also states where you switch from like one state to a radically different state, and there's a big kind of functional break there, and maybe a break in memory, right? Those kinds of things, then raise questions about countability. But I don't think they raise any questions about personhood, about whether you're, as Sophie aptly put it, at least one person, right?
thanks you all.
Okay, no one in line. I think we have some time for a final question. I would like to make. I will try to be brief. And I was thinking about an explosion of indeterminacy. Like you guys skip a little bit about the criteria for mind, right? For what is mind, what's going on, but you tackle process, right? Perception, memory, action, they are involved. And I was thinking that your examples might pressure a little bit the frontier, the boundaries, the frontier for these concepts. Like how can we, if we have problems determining where is some minds, maybe we have problems also for determining where is perception, memory, and action, and then we end up with we don't know anything, right? Everything is very indeterminate.
I agree. I think it's very hard to figure out exactly where perception and memory and action would be localized in the brain. And I think it's probably not the case that like there's just a determinate set of neurons involved, and there's a determinate set of countable neurons that are involved, and a determinate countable set of neurons that are not involved, such that like, if, in principle, a brilliant scientist could present you with a list of all the neurons that were involved and a list of all the neurons that aren't. I think there are probably, there are probably some parts of the brain where it's not quite clear whether or not to say they're involved. I think there's also probably massive indeterminacy even with where brains are. So like, where exactly does my brain end and the rest of my body begin? Where exactly does my body end and the outside world begin? You know, if I have like a piece of bacteria on my skin that's been there for a while, is that a part of my body or not? If there's like a cell of skin that's just dying off, is that a part of my body or is it not a part of my body? If I have a if I have a neuron that's just entering a certain kind of death, is that a part of my body or is it not? I mean, I don't know how to answer those questions, and I'm not even sure I know how, in principle, we could find answers to those questions. So all of that is to say that, yes, I think you're right. I think there may be massive indeterminacy, and at the very least, I think there's massive uncertainty, even if ultimately there are stricter boundaries in the world than we might think that there are just from our observations of the natural world. It's far from clear where those boundaries are located.
Thank you so much. Thank you, Sophie. Thank you, Eric. And now we will push forward. Let's get continued with the session with Professor Robert Rupert's presentation entitled Group Minds and Natural Kinds. Robert Rupert is Professor of Philosophy at the University of Colorado. He has a PhD in philosophy from the University of Illinois. His research focuses particularly on mental representation, concept acquisition, mental causation, cognitive architecture, situated cognition, group cognition, natural laws, and properties. He has held visiting research positions at the University of Edinburgh, the Australian National University, and the Ruhr Universiteit Bochum. He is co-editor-in-chief of the British Journal for the Philosophy of Science. Professor Rupert, the stage is now yours.
Thank you. Let's see if I can take the next step here. All right. Are we advancing properly?
Yes, we can see it perfectly.
Awesome. All right. I'll give you a quick outline of the talk. I should say first, thanks to Luis and Anderson for arranging this and for all their work on the book and the translation. It's much appreciated. I'm happy to be included. The outline for this specific talk begins with List's argument, that is Christian List's argument for realism about group cognition. I will then give a kind of argument from parsimony against realism about group cognition and consider an anti-reductionist rejoinder. I will then consider a realist argument, again, in favor of group cognition, an argument from functional identity or strong similarity, and consider the challenge of functional differences. I think this is a very serious challenge to the argument from functional identity. And then I'll make an attempt on behalf of the realist to exploit a kind of thin notion of sameness of kind, and problems with what I call a thick notion. Maybe a thin notion will work, but I'll raise some difficulties for that approach as well in the end. All right, onward. Realism about group cognition, group minds or group cognitions. I'll say that I will start off by including the term minds, group minds, but as I move along, I'll be talking primarily about cognition. Part of this is because I think if there are mental states, then cognitive science will find them. Maybe an excessively naturalistic kind of view about that. But also, just to back off a little bit, you might think, well, at least even if minds are distinct from cognitive processes or cognitive states, they're at least where there's a mind, there's got to be cognition. And any place a mental state is located, there'll have to be cognitive states, processes, or whatever. So if it turns out that some region doesn't have any cognition in it, then it won't have any minds either. So certain kinds of arguments about group cognition will, bear really strongly on questions about group minds. All right. In many this is a statement of realism. In many actual cases, collections of individuals who themselves have mental or cognitive states, have mental or cognitive states of their own. For example, the typical corporation has its own mental or cognitive states as genuine mental or cognitive states of a single entity. So corporations are one example that's given. Courts, unions, smaller groups, more or less in less formal settings like musical group. Anyway, so you get countries, I guess is an example that Eric has discussed. This is not a matter of metaphor or figure of speech. It's not, metaphorical, like everyone blamed Joe. He was the sacrificial lamb. Well, of course, we know the context. I'm imagining Joe is not a lamb. Joe is a person. That's metaphor. We're not talking about that kind of case. That might be the right way to read some claims that are made when people say, England wants to retain the pound as its unit of currency. Maybe they are just speaking metaphorically. But the realist about group minds, group cognition would say, no, England really has a mental state, a desire to retain the pound as its unit of currency. This is not a claim about an average over individual cases. Like the average American household has 3.13 members, where in that case, the syntax of the sentence, the surface syntax suggests that there is an entity, the average American household, that has 3.13 members. It's not the kind of situation I'm thinking about. Again, the realists mean that literally the group as a single entity has belief, desire, whatever, memories, and so on. Okay, here's an argument. For Christian List's somewhat recent paper now in Noose. List in this paper is arguing against group phenomenal states, but he is a realist about group cognition, and he sets up the discussion by summarizing his support for group cognitive states, even if there are no phenomenal states. So here's how he summarizes it. It's a bunch of, based on a lot of work that he has done individually and with Philip Pettit over a long period of time. List says, offers this argument. Premise one, our best social scientific theories of certain social phenomena, for instance, our best theories of the behavior of firms in the marketplace, attribute belief, desire, agency of the functionalist kind to some of the collectives involved, often by representing them as agents in the decision and game theoretic sense. So intermediate conclusion, according to a naturalistic definition of ontological commitment, those theories are then ontologically committed to group agents. Premise two, we should at least defeasibly take the ontological commitments of our best scientific theories in any given domain at face value. And I will read this charitably to mean, so long as those theories have met some kind of minimal threshold of success, in some cases, our best theory might still be really crappy, might be garbage. So I'll set aside that concern. Conclusion, we should at least defeasibly take our best social scientific theories commitment to group agents at face value. Again, this is from List's 2018 newspaper. What is it like to be a group agent? That's all direct quote. All right, well, here's an argument on the other side. It's not super helpful. We're just going to bash these two arguments together and talk about where the disagreement lies. An argument against group level cognition might go like this. Take a principle of quantitative parsimony. I think I first came across this term in a paper by Daniel Nolan from the 90s in BJPS, but I'm not sure if he was the first one to introduce it. Having found reason to posit entities, states, or processes of a given type, spread them around as little as is necessary for one's causal explanatory purposes, other things being equal. Cognitive states and processes of individual humans suffice to account for the phenomena of interest, the observable output of group activity. Therefore, there's no reason to posit group states and processes. A simple idea is just take any one of these examples that are meant to be examples of group mental states. You say, well, what is the phenomenon that the positing of that state is meant to explain? Right? Maybe someone says, Microsoft wants to develop a new version of its operating system. Okay, it sounds like Microsoft, the corporation, has a desire. But it's easy enough to go through, especially if you have lots of knowledge of corporate structure and corporate processes. You can go through and say, what that really amounts to is that the CEO conferred with members of some executive committee or executive board, and they talked to some engineers, and they put together a working document, and the working document was reviewed by some other people, and it's the people and their interactions. And there's that could fully explain why a certain, research and development strategy is being pursued at Microsoft right now. All right, but okay, so we have these two conflicting arguments. What is it that folks like Christian List and Philip Pettit think needs explaining? Why do they think why do they think these social scientific theories are offering something distinctive when they posit group level states or processes features? So one kind of case that Pettit and List discuss is the case of the doctrinal paradox. In cases of judgment aggregation by vote, an outcome can vary depending on whether the vote follows a premise-centered procedure or a conclusion-centered procedure. I'll tell you what those things are. The premise-centered view, if you follow the premise-centered approach, then members of the group vote only on individual premises. Logic then dictates the truth value assigned to the conclusion. I'll give you an example momentarily. On the conclusion-centered approach, members of the group vote directly on the conclusion only. All right, so here's an example. Okay, so you've got a court case. Let me just describe it without too much reference to the slide initially. So someone's suing, it's a tort case, someone's suing for breach of contract. Two questions arise. Was there a valid contract? And if there was a valid contract, like assuming there is, was there a breach of contract? The actions of the defendant, did they constitute a breach of contract? If there was one. Right. Defendant then, now looking at the slide, the defendant is liable only if both things are true. We've got a 3-judge panel. They take a premise-centered approach. They look at P, the first question, was there a valid contract? Judges 1 and 2, they have ones next to their names or their descriptions anyway, in the column, the first column. Judge 1 and 2 both vote, yes, there was a valid contract. So P gets a 1. Judge 3 says, no, there wasn't even a valid contract. When they turn to the second, and I should summarize, because this is a premise-centered approach, it's 2-to-1 on the question of whether the first premise is true, that there was a valid contract. And so the majority holds that there was a valid contract. When it comes to the second question, assuming there's a valid contract, would this behavior have been a breach of contract? Then Judge 1 continues to vote the same way. Yep, that was a breach of contract. Judge 2 says no. Judge 2 thinks there was a valid contract, but no breach. Judge 3, who did not think there was a valid contract, does think there would be a breach of contract if there had been a valid contract. So on Q alone, you get 2-to-1 again, and truth value of 1 of true as the majority's view on Q. Now we follow the logical implications of the rule of inference here is just simple conjunction. The conclusion is a conjunction, but of course what's interesting is that conjunction entails liability. So the conclusion is, on a premise-centered view, that the defendant is liable because the majority's view, 1 and 1 on the two premises, would entail a 1 on the conjunction. Now, I think I might have misspoke a minute ago and said the court here took a premise-centered view. This representation, when you get to the conclusion, shows that the court actually took a conclusion-centered view and said, well, despite the fact that the majority voted in favor of each of the premises, only one of the 3 judges voted yes in both cases and would actually hold that there is liability. So you get tension in these cases. One of the things that bothers, I think is especially bothersome to List and Pettit, is the case where a premise-centered view is followed, and so you would actually have a 1 on the bottom right, where it says 0 majority, bottom of the conjunction column. You'd have a 1 because the court follows a premise-centered procedure. And since both premises were true, the conclusion would be held true, even though only one of the three actually believes that there was a valid contract and a breach of contract. This kind of mismatch argument has been used by a variety of authors. Margaret Gilbert comes to mind as someone else who said this kind of thing, who said, look, there's a belief that you attribute to the group as a whole, like manifest in their behavior, that none of the individual people has, or in this case, not only a minority of the individuals have. So it can't just be that what we attribute to the group is a reflection of the majority view. That's the kind of worry here. So if you look back again at the case where, didn't realize there was a 0 here on the bottom right, my apologies. If you look back at the case where there is actually a premise-centered view being followed and the conjunction is held by the court to be true, then you've got an opinion coming out of the court that only a minority of the court members follow. So there must be some other entity that's exhibiting agency here, or has the view, and that entity is the court as a whole, as a group. All right, let's look at conflicting diagnoses. I just gave you a sense of what Pettit and List's diagnosis is. Many courts rule P and Q in such cases, thus manifesting rational processing or mental states or the presence of an agent, something like that, over and above what's delivered by an individualist approach. We should endorse group-level cognitive processing or mental states, et cetera, as part of our best causal explanatory account of the social phenomena of well-functioning judicial institutions. That's the kind of make contact there with List's first premise about our best social science. I chose this example because it's kind of tidy logically, though it may not seem like the perfect example of social science at work. It is a kind of causal explanatory account of the social phenomenon of well-functioning judicial institutions. Well, let's look at the contrasting parsimony-based approach. We know perfectly well why the court opinion reads the way it does. It's because the individual justices are committed to a premise-based approach or to following precedent or whatever. Anytime you have one of these mismatches, it's going to be for a reason. It's going to be because the individual justices agreed to an opinion on the basis of their individual reasons. So all of the cognitive contributions necessary to understand or explain the phenomena are individual states and processes of the judges. It would be gratuitous to also attribute a mental state to the group as a whole. Just for the reason given. There's no mystery that needs explaining here. Once we've attributed the full range of cognitive states, processes to the individual judges that we have reason to attribute anyway. This is the kind of cognitive, Occam's razor sort of approach here. We've already have reason to attribute those things to the judges. Then just, stop there. Don't spread cognition around any farther. Now, there has been some response to this kind of view in the literature, these worries about parsimony. Pettit and List then try to anticipate some of this in their book on the topic from 10 or 15 years ago. These various kind of responses, they appeal to anti-reductionism, claims about supervenience, claims about how best to handle causal competition and how all this interacts with levels. I don't want to go through all this except to flag the sort of red herring, I think, that's at work here. Responses that appeal to anti-reductionist views, to supervenience, or to a liberal approach to causal competition seem like red herrings. They seem to miss the point. The question is how widely to spread cognitive properties around, how many instances of one and the same kind of property we should recognize in order to model the phenomena, the full range of phenomena we're interested in. Once we've admitted cognitive states and properties into our ontology, then we ask how many instances are required to do the causal explanatory work. It's a very different kind of question than the question that is being answered in cases of supervenience, causal competition, and anti-reductionism is a little more complicated, but there as well, I think, as it might apply in this case. The question I'm asking, the question I think we should be asking about quantitative parsimony, is a question about a homogeneous collection of properties. The questions about reduction, supervenience, or causal competition concern distinct levels or distinct sets of properties. I think part of what's at work here is the confusion about levels that arises for the following reason. You've got this tradition of thinking about levels from like Putnam and Oppenheim that has to do with the individuals, like the entities involved. So you've got, subatomic particles and then atoms and then molecules and so on. But there's another kind of level that has to do with the laws and the properties involved, like what properties cluster together at levels. Cognitive properties are all, I'd say, one level. So it's not a question of reduction so clearly in that case. What does seem clearer, especially in the case of supervenience, supervenience is normally described as a relationship between different sets of properties. Do mental properties supervene on physical ones? But asking whether some mental properties supervene on other mental properties, or whether some cognitive properties supervene on others, is a different kind of question. And I think there we should be perfectly happy to say, oh no, if that's what you're thinking, then the former are just extra. If you think some mental properties supervene on some other mental properties, and you've got a perfectly good explanation of why the former, you might have thought the former exist or instantiated, then we just do away with the extra ones. Or so the parsimony-based thinking goes. There's one other kind of argument here that might deserve special mention. It's a kind of interventionist anti-reduction that Pettit seems especially moved by. There's a kind of epistemic opacity to individual processes, it's sometimes thought. So much so that we don't know how to intervene on the individual level so as to change the results. I guess what's common to this discussion from the previous slide and this one is the following kind of idea, is that we should be thinking about the relationship between groups and individuals in the same way we think about sort of the personal level and the subpersonal level. And so, we have processes for attributing kind of personal level states. We have guidelines, we have principles of charity, and who knows what all, you want to put into your theory of the attribution of personal level states. And then there's a kind of mess of stuff going on subpersonally. And a lot of that stuff is like neural, and we don't really know how it maps on to the personal level stuff. And it's also opaque that, at least for epistemic purposes, we're kind of forced to reify the personal level, to treat it as its own, autonomous or semi-autonomous level. But and you might think of this, you might pitch this in terms of intervention, as Pettit does some of the time, saying that like there's so much epistemic opacity that we don't even know how to intervene on the individual level so as to change the results, which may, at least with regard to some features of the mind, especially maybe going back a little farther into the history of ideas and science, you find this may have been true. Nowadays, we have a better and better idea how to supervene on the neural level to make so-called personal level stuff happen. But imagine, there's this opacity at the subpersonal level. We just don't know what to do, so we attribute personal level states and we operate on that level. We operate in those terms. Is the same kind of thing happening here? Pettit seems to think so, and I can't see it. It seems false empirically. When it comes to courts, corporations, unions, etc., it's no mystery at all who to talk to in order to change the results. Like in a situation in which the three justices have endorsed the premise-centered approach to decision making, then obviously they're the people to talk to try to get them to change their minds, to get them to endorse a conclusion-centered approach instead. And if this is a matter of, policy at the level of the bar association or something, then you go and talk to the executive committee of the bar association. I mean, when it comes to big groups, it's especially clear in the government case, there are whole industries that are aimed at lobbying the individuals whose contributions will then make a difference to the group decision, which may be a policy decision coming out of Congress. All right. Well, let's try a different tack on behalf of the realists about group states. It may be that we find a kind of functional identity or similarity, at least, that's sufficient to attribute cognitive states to the group, even if those states aren't playing an obvious causal explanatory role. Right? So you might defend realism about group cognitive states by attempting to show that our best cognitive science entails the instantiation of group states as a direct application of a theory of cognition suited to the individual level. And the idea, part of the idea here is that, you know, you might discover the existence of a particular kind of entity, an element in the chemical domain, for example, by observing its effects and then modeling those effects. But as a result, the best account of those effects might be a chemical element with a certain structure. And then wherever you find that structure is that chemical element for then after. And it doesn't matter that the other instances of that element that you find aren't having the effects that you're originally investigating. Maybe they're isolated. They're not having many effects at all, right? But once you've committed to the existence of these chemical elements and you've given an account of their, compositional essence, or, at least necessary and sufficient conditions nomologically for their appearance, then you're committed to their existence wherever that structure appears, regardless of the effects they are or aren't having. So that's the kind of thinking behind this. After we've got a successful model of human cognitive processing, we might find out that the states described by the model appear in groups as well. That approach, if successful, like on behalf of the realist about group cognition, would seem to neutralize the concerns from quantitative parsimony. But on the other hand, there are so many differences in the behavior, in the phenomena observed, that some cause for skepticism. Get some of these on the table. Individual humans engage in a wide range of forms of complex behavior that groups do not exhibit. And notice, like, a lot of these forms of behavior, I'm only going to describe a couple or few. A lot of these forms of behavior they're like the touchstones of cognitive science. It's the stuff that starts the whole enterprise. So that doesn't mean that cognitive science must forever label these things cognitive forms of behavior. There can be bootstrapping as we understand the processes that produce the behavior better and better. It might turn out that some of the things we initially thought were cognitive don't actually fall into that category because they're produced by a very different kind of process. But there's this ongoing interplay between, observation and modeling and recategorization of some of our observations is standard kind of scientific stuff. But it is worth noting that there is, as in any other science, cognitive science starts off with, a range of things that seem kind of interesting, like they might have a unified theoretical explanation. This might be language use, certain forms of social cognition, the production of the Greek works of art and architecture, design of experiments, theory construction, and so on and so forth. I give a couple examples here of kind of complicated long-term phenomena. Practicing and mastering an instrument, then securing a position with a symphony orchestra, and then performing with the orchestra, or going through the process of helping one's offspring to select a college by reading brochures with them, making appointments for them with their high school counselor, signing them up for college entrance exams and helping them to access and interpret their scores, taking them to visit campuses, and on and on. And examples of this kind are everywhere in our daily lives. I give a couple of other ones in the paper that have to do with parenting and dating and things like that. And groups just don't do any of this stuff. Right? So if you're looking at things in this grain, it doesn't look like there's just sort of any reason at the outset to expect that there will be sameness of process or states across groups and individuals. So we have this initial reason to doubt that groups have the same states as individual humans. They don't produce the same outputs or anything like it. So that might make one doubt sameness of functional role. But there are other possible, like, to be a little less skeptical, like we should be trying to find other kind of rationale for attributing states of the same type, the same functional type, say. As many of you might have gathered by now, I'm ignoring phenomenal consciousness. I think that makes the case harder, although, Eric disagrees, or at least thinks that can be solved. A good case for realism can be made about groups in that situation. I think generally speaking, it's a lot harder to make the case for phenomenal realism about groups. So I'm just setting that aside and focusing on cognitive states. But because I'm focusing on cognitive states, I'm thinking very functionally. And so a lot of this is about functional roles. So if you're thinking in terms of functional states, you can have same states across systems, but very different manifestation conditions, right? So, you know, you think about the standard representations of mental states offered by functionalists using, say, Ramsey sentences or machine tables. Those kinds of characterizations allow that it can be part of the very individuation of or identity of a kind of mental state, that it produced certain kinds of outputs, but only in the presence of very specific conditions, and conditions that maybe groups don't ever find themselves in. Like if groups could have babies, then groups would do a bunch of the stuff that parents do. If groups did have kids who make it to high school and go off to college and go to university, then groups would do a lot of the stuff that I've been talking about, or was talking about on the previous slide. So it's, you know, we don't want to be too impressed by these differences when we look at the kind of details of a typical human life and we catalog all these struggles, trials and tribulations and victories and projects and all this stuff from real human lives, and then say, but groups don't do that, or they don't do most of that. So, you know, I'm going to be skeptical about the sharing of human states and group states, like that they would be of the same type. When you go down that road, and it's not uninteresting, but we also want to recognize that there can be sharing of states with very different manifestations. I mean, just to leave the cognitive domain, just think of carbon. You have sharing of an element among a wide range of things that exhibit different kinds of manifestations, or, you know, measurable behaviors. We also want to think about general states, state or process types, right? So, you know, it might be that a group doesn't have the same desire that an individual might have. The group might not have a desire to join a symphony orchestra, but it's a separate question whether the group has any desires at all, or any memories at all, or any perceptions at all, decision-making, planning, so on. And we might say some similar things about subtypes, like working memory, vision, planning of a path movement, right? So a specific type of planning, a specific type of perception, a specific type of memory. Some of the, you know, you can get more specific into kinds of mechanisms. There's a paper, I'm trying to remember now, by Georg Theiner and co-author Rob Goldstone, where they invoke lateral inhibition mechanisms. So lateral inhibition, it plays a role in vision. And so you might find that some groups have what is structurally looks like mechanisms of lateral inhibition in the structure of their group dynamics. And so maybe it's, you know, worth going down even to a finer grain than what I have labeled subtypes of or general process types. It's also important to keep in mind general properties of output. Now that shifts gears a little bit because we're not talking about the internal states anymore, but it is in a way part of a tempering of the argument of the previous slide, or the at least the intuitions connected to the previous slide about symphonies and sending kids to college. Because, you know, a lot of what we think of when we think of intelligence or cognition is more general than these specific manifestations of it, like decision-making about colleges or college choice. It's the general phenomenon of flexibility in problem solving via, say, an ability to switch tasks as appropriate to the context, or ability to switch strategies in the approach to a given task. Okay? So there might really be the sameness of explanandum across cases, groups, and individuals if you look at the explanandum the right way, as, say, flexibility in problem solving. Back to sort of questions about internal structure or states. It's also worth thinking about our architectural design. This could be a kind of thing that's shared across groups and individuals. Maybe this would include some of what I said about lateral inhibition. So, degree of modularity or the structure of the modules, the way they're interconnected, I guess related to that, which I didn't put on the slide, are things to do with, patterns of connectivity that you get from graph theory, small world architecture or something like that. So that kind of thing, mechanisms for detecting contingency between properties. This might be one of the kind of things that you need in order to behave flexibly at all, in order to learn at all, or to suit your behavior to the environment, is you have to have some mechanism for detecting the co-occurrence of features and the strength of co-occurrence, to what extent one can be predicted on the basis of the other, asymmetries in that regard, all this that kind of thing. An architecture might also include mechanisms for gating. For example, determining which of a number of simultaneously activated processes controls output. I think Sophie mentioned some of these earlier, things like, first to the finish kind of architecture. We have multiple categorization processes happening at the same time, and the one that produces the output is just the one that finishes first. But you might have a different architecture that waits until all of the quasi-independent processes spit out an answer, and then your architecture goes with the answer that has the highest confidence rating associated with it, or something like that, right? So there are different ways of handling, for the purposes of determining a single output, there are different ways of handling simultaneously activated processes that are working on the same task in some way or another. Right? And so these kinds of considerations, like I haven't really argued for any particular view here. I'm just saying there are lots of things to consider when you're trying to figure out whether the group has important properties that the shared with individual thinkers, individual humans. Okay, but that brings me to a note about the big picture. I just emphasized sharing, and I want to continue to emphasize that, make it very clear. When I've given talks like this before, sometimes people think I'm arguing for some kind of human superiority or making some kind of value judgment. I'm not interested in making value judgments at all. Like that only individual humans engage in true cognition, and that makes them special or better than groups or better than animals or better than AI or what have you, plants. That's not part of the project at all. I don't much care what words people use. Maybe there's some argument for linguistic conservatism, but that would be kind of a separate issue. My point here is just to ask about sameness of kind. That's all. That's what differentiates the kind of realist position from the metaphorical position, or the metaphorical approach to the attributions of group states that I talked about at the outset. The point here is, like, regardless of what we call states or processes appearing in individual humans, and regardless of what we call the states or processes appearing in groups, I want to ask whether the former and latter are of the same kind. It's all, sort of all that matters to me. Do they share a genuine natural property? That is, a property that would be included in a so-called completed science. At least that's one way to think about what natural properties are. All right. They're like Lewis's sparse properties, roughly. Okay, the dilemma of thick versus thin. I think a dilemma afflicts a lot of these discussions. Afflicts the discussion of generic state types, their subtypes, and architectural design or structure, those items from the previous slide. And the problem is this: like, we can choose between characterizing them in a thick way, and I'm getting this, I guess, from kind of moral theory, right? Describing their nuances, their dynamics, structural components, features of the interactions they enter into, all that nitty-gritty stuff. If you do it this way, it's almost certain that extant groups will not do not instantiate the same properties as humans. That kind of takes us back in the direction of the college selection process and the decision to pursue the mastery of an instrument and the joining of a symphony and all that kind of stuff. Right. but it's not just those big kind of life decisions. Those were good examples. They're fine examples. But it's also true when we think about mechanisms, things like memory consolidation, right? The still a contested area, but you've got this whole story about how episodic memories are first encoded in hippocampus, and then during your downtime, possibly sleep, other times as well, you get the shunting of those memories to frontal cortex, and then, well, there's some traces left behind, and the, you know, how this whole process works, how the consolidation or cementing of memories is affected by the extent to which they jibe with existing semantic knowledge. How that works is, well, it's clearly an issue of some import, even if the details haven't all been worked out. There's some effect there of kind of, you might say, coherence. The way semanticization then works over time as the episodic memory is sort of loses its rich detail and turns into an encyclopedia entry, right? All that stuff. When you think about, oh gosh, is that really what's happening in the court or at Microsoft? It just looks really implausible as you describe in a thick way what the important processes and states are in human cognition. And this is particularly true if we treat functional roles holistically. Right? I mean, it's kind of, because remember, if you treat them holistically, then the relationship that a given state enters into with every other state in the psychology of that being is partly individuative of that state, of the first state. Right? Every sentence that you might say as a result of being in a certain mental state is part of the individuation of that mental state on a holistic functional role-based treatment. So, I mean, if you think about it that way, then groups that don't have linguistic capacities could just, you know, to produce a statement as a group, whatever that exactly amounts to, they just couldn't be in any of the same states because there's this massive element of their holistic functional role that would be missing. You might say, well, functional roles are contingent on what other stuff is present, and maybe that other stuff isn't present. I hinted at this earlier, but there's got to be some limit to that. You don't want to say a single neuron has a whole bunch of mental states. A single neuron in a petri dish has a whole bunch of mental states because it could play the role of a grandmother cell if it were connected to a whole bunch of other stuff that it's not actually connected to. Well, that doesn't mean right there in the petri dish it's a grandmother cell, a detector of grandmothers. So, you know, our holistic functional role characterization has got to be limited in some ways to what the creature in question or the system in question is realistically going to, what other states that creature in question is realistically going to instantiate, without hooking it up to a bunch of other stuff or adding a bunch of material. Our alternative is to characterize state types in a thin way, just trying to find some common thread to the two cases of individual humans and groups of humans. But if we do this, we risk identifying a common thread that does no causal explanatory work and is thus ontologically irrelevant from a naturalistic standpoint. I'll say what's also pretty interesting and may well be more likely be the case with groups and individuals is that we might be able to find common threads that do some causal explanatory work, but it's such a small amount as to be kind of scientifically irrelevant for the most part and ontologically irrelevant. All right, so let's look at the case of the biggest picture thing, cognition. You might say being a cognitive system or cognizing. How would you approach this? Well, we might think, okay, what is the distinctive output of cognition? Earlier, I mentioned flexibility. Maybe that's it. So you start with cases in which groups exhibit flexibility in problem solving. Again, the ability to switch tasks, the ability to switch strategies in the approach to a given task. and cases in which humans do. Like you look at groups doing this, you look at humans doing this, you try to figure out whether there's something there they share. Is something shared by the respective processes where that something does have causal explanatory or does do causal explanatory work with respect to a feature such as flexibility and problem solving? Maybe it's something like degree of integration of components that can be varied in both systems. For the human or for the group, you can do experimental manipulations and vary the degree of integration of the components. Humans, maybe you give the human drugs or you use transcranial magnetic stimulation. You do something to kind of scramble its degree of integration or something like that. Or maybe you find people who have suffered lesions. And you look to see whether those variations, say in the degree of integration, measured the same way across the two systems, corresponds to some varying outcomes, some measurable outcomes seen in the data. In this case, it would be the extent of flexibility. Maybe you have some measurement of how efficient the group, the individual are in flexibly solving problems, changing things up in the face of roadblocks, for example. All right. Well, here's an approach. In the published paper, there's a whole bunch of detail here about what a cognitive system is, and it's very much in the weeds, and I'm not going to go through that. But I'll give you a sense of what my view is. It's that a state is cognitive only if it's the state of a mechanism that is a component of the cognitive architecture, broadly speaking. What's a cognitive architecture? That is the relatively persisting collection of mechanisms that co-contribute in overlapping subsets to the production of a wide range of forms of intelligent behavior. This is what we seem to have in the brain, for example, though I don't want to be necessarily, location specific. I want to be location neutral. Maybe your iPhone could be part of this, what have you. But it's what it looks like is that humans have a collection of a whole bunch of mechanisms that can contribute to a wide variety of forms of behavior, whether it's conversation with another person, or whether it's writing a book, or whether it's riding a bicycle, or making an appointment with a doctor. Any of these things, right? And on and on and on. Certain of these mechanisms are obvious ones, like a working memory buffer, which is going to contribute along with other mechanisms to a wide range of forms of intelligent behavior, but not necessarily to all forms of intelligent behavior. Anyway, picture's worth 1,000 words, so let me jump to my picture. This is from a paper by David Amodio from Tics, Trends in Cognitive Sciences in 2019. Amodio thinks, based on lots of experimental work and theorizing, that there are 5 memory systems: episodic memory, semantic associative priming memory. There may be more than 5, but these are 5 primary ones. Instrumental memory, aversive conditioning, habit memory. And that, the reason I like this picture, is that they contribute in various combinations to the production of various kinds of behavior. Planning or prospection related behavior is on the top right, what Amodio labels the response channels. And so semantic associative memory and episodic memory combine to produce planning. If you look at impression or judgment, Amodio is a social psychologist, so a lot of what he has in mind is sort of impression of other people, how you judge them immediately in social contexts. And here you've got instrumental conditioning, just sort of reward-based conditioning that's not specifically about the aversion to something noxious or whatever. That's separate system, the aversive conditioning system. But just general instrumental learning together with semantic association, together with episodic memory, those 3 arrows, red, blue, and green, all point to impression, judgment, and so on. So this is the kind of picture I have in mind. I would generalize it, and I would include lots of more specific mechanisms. I think cognitive science is going to, we're thinking about the cognitive system as a whole. It's going to be hundreds or thousands of mechanisms involved that the mechanism that infers shape from shading in the visual system, for example, all this kind of stuff. Okay, so problem of thinness seems to arise with a vengeance here. Being part of such a system of mechanisms that contribute in overlapping subsets to the production of a wide range of forms of intelligent behavior, being part of a system you might think is binary. Either activity is or isn't taking place in such a system. And similar remarks apply to other approaches. For example, Edwin Hutchins' claim that the boundary of the cognitive system is the steep drop-off in the computational gradient. I chose Hutchins to mention here partly because he's a seminal figure in the study of group minds, generally speaking, group cognition, distributed cognition across groups. He was studying military boats, San Diego Harbor. And, you know, there it's, maybe the deck is stacked in a certain way in that case, because you've got all the sailors on the boat, and then there's suddenly a drop off to the water, like the boat ends and there's a nice clean boundary, physical boundary. And so maybe it's no surprise that when he was thinking about the group as a single computational system solving navigational problems as a group, he would say, oh, well, the computational gradient suddenly drops off at the edge of this group, and that's what makes it a single mind. But regardless, I mean, that's a proposal, and it's a proposal that if you think there are steep drop-offs, then it's a proposal that gives you a kind of binary, at least as a necessary condition for cognition. It has to appear inside of one of those systems, and something will either be in that system or it won't. But if a view of this sort is right, concern is that simply being part of such a system accounts for almost nothing of interest in the data and kind of working cognitive science. It's a necessary condition for the production of interesting behavior at all. It's kind of like the distinction between being dead and being alive. But the kind of work cognitive science typically does involves testing for the effects of experimental conditions on performance on specific tasks. That's, it's constantly being done. We're going to give you we've got a control condition, we've got an experimental condition, and maybe there are 4 or 5 variations on the experimental condition, and there are 4 or 5 experiments then reported in the paper. And this is on a specific task. It's not whether you're dead or alive or whether you're functioning at all or not at all. That's just not really what cognitive science is all about, beyond like meeting this base level condition of being a system that's capable of, responding to instructions and performing on the task at all. So this approach might deliver group cognition or group mental states only in a sense that it meets one of the fundamental, like the groups meet one of the fundamental conditions for producing behavior that could be of interest to cognitive science. So you've got a shared property across the individuals and the group, but it's this very thin property of being integrated, sort of like being a system, being an integrated system or not being. Well, interesting, but how specifically cognitive is that? Like that alone really isn't producing even flexibility. You've got to have a deeper story about the mechanisms that allow for flexibility. I think some of that comes from having a bunch of mechanisms that produce various forms of intelligent behavior in overlapping subsets. The overlappingness is part of what allows for smooth transitions from one task to another or one type of strategy to another. Because if you've got 2 overlapping sets, one responsible for one behavior and one for another, then switching from the first to the second is already primed by the activity of the shared units. So you've got some kind of plausible story about how flexibility emerges from the way in which the integration is affected. Do groups, so in order for there to be a shared property of interest to cognitive science, though, then groups would have to share not just some measure of integration, but actual kind of structural properties about how that integration produces behavior.
Rob reached 50 minutes.
Excellent. This is my last slide. I'll just give you a parting thought. Cognitive science is, to a great extent, an applied science. We want our cognitive science, for example, to help us to teach reading more effectively, to improve memory function in the elderly, to get teens to exercise more self-control, to reduce implicit bias in hiring, and so on. It's not that abstractly characterized processes such as task switching, say, are irrelevant, but notice that in pursuing the applied goals of cognitive science, What's important is the specific profile of task switching mechanisms as they form part of the human cognitive architecture and function within that architecture. And I'll leave things on that note. Thanks.
Okay, thank you, Rob. Thank you so much. And now we have some time for questions. Okay, Eric, please.
Hey, yeah, thanks for that. I want to make a plug for pretty coarse functional individuation being sufficient for cognition, rather than having to be as thick as you're suggesting. And one of the ways that I am inclined to think about it is to think about hypothetical alien cases, which I know rubs some people the wrong way, and maybe you're among those people. But still, I mean, there really is a science of exobiology or astrobiology, right?
Indeed.
So I think if we came across an alien species that acted in a sophisticated and flexible way in response to its environment and overcame challenges and communicated linguistically and could communicate linguistically with us, it would be pretty hard to say it didn't engage in cognition, even if even if it didn't have, episodic memory consolidation that works like we do, or, the kind of thick stuff about orchestras and all that, right? It seems like, as long as you've got some pretty coarse kind of rationality and communication and action and perception and memory, all pretty coarsely defined, that's enough for saying you have a cognitive system. That's a general thought or general reaction that I wanted to solicit your further thoughts about.
Thanks. Yeah, that's the way folks, a lot of my contribution here has initially developed, or at least in tandem developed, with work on extended cognition. And that's the way Dave and Andy have tended to respond to this kind of thing too, in that context, which is to say, no, there are these coarse-grained categories that are interesting. And I'm more of a mind, I see this as a dilemma. It's okay. Well, let me step back, really, because I think there might be an initial point that we may disagree on. I'm not sure. I think cognition is a scientific kind because I think everything's a scientific kind if it's real. So I would want to know, what is the thing that we share with them that does causal explanatory work in any substantive way? So, I understand the intuition of hey, their behavior looks cognitive, but and it looks like the sun is moving across the sky. I guess I'm not very moved by those until you do the work and you model a phenomena. And it looks like if it turns out that they're using language because they have these outrageous computational resources and they've got lookup tables, then I might think, well, that's not the same process. It depends on how it's done. What is the thing that we share that contributes, in virtue of just what's shared, contributes to accounting for variance in the data and sets of data across the two cases?
Could you do something like, economic rationality models?
Yeah, I guess some of the worry there is that economic rationality models are too idealized, that they don't actually explain, they don't do much work if what you're trying to model is human behavior in the marketplace. So, I think some of the concerns that I raise would re-arise there is that most of our decision-making in the marketplace is driven by proxy factors, A, B, C, and D, and none of those are really applications of idealized decision-making in the marketplace. And yeah, that'd be the worry. Yeah, but I'm with you. We should try out, whatever abstract resources that we can. I just think humans are really kludgy. Sorry, go ahead.
Yeah, one more thought about that. I'm sorry, I'm maybe going on a little too long, but
Oh no.
I wonder if there's a broad difference in perspective that what you just said it points to that might be underlying some of this, right? So, my inclinations in philosophy of science are pretty Stanford school, right? So all scientific theories are idealizations and approximations, and they get it right to some degree for some purposes, right? So yeah, so economic rationality models famously don't work super well in lots of cases, right? But that's true of gravity models, right? Because there's electromagnetism that's not being accounted for, and friction and stuff like that, right? So it's just a general fact about scientific models, right? So the kind of, the anti-reductionist, pragmatist, Stanford School approach says, hey, look, you've got a model, maybe it works at a coarse high level. Don't worry about whether it's perfect, and the kind of ideal of reducing it to the things that really do the explanatory work. That's a very different kind of vibe in philosophy of science. So I wonder if part of that is going on here too.
Yeah, no, that's a good point. I think, moved by something closer, not entirely, but something closer to an anti-Cartwright sort of view. And so we do.
Oh, but I think of her as paradigmatic Stanford School.
Yeah,
closer to. So now I'm totally confused.
All right, well, let me explain what I'm taking. What I think I'm taking.
Okay.
Cartwright. It's the nomological machines kind of stuff. When you do you can do isolated experiments where you see the effects of just gravity or the effects of just economic rationality. But here's where I would probably then part ways with Nancy, is to say like, oh, but we can actually model what's going on in more realistic, messy cases. It's going to be a combination of a bunch of factors. It will be the abstract structure of economic rationality together with the mechanisms of group identification that make us want to buy certain things or invest in certain things because Bitcoin is really cool right now, or whatever drives people to make the decisions they do that isn't a reflection of economic rationality. So you model these cases, and the way that what I've been saying in this talk would fit in is then you'd say, look, how much of the different factors that are all included in the model, how much of the variance is accounted for by variation in any one of these factors? And the claim is that when it comes to kind of a theory of cognition simpliciter or something, cognition as a generic kind, that variation won't do much work, variation in that. But it's worth looking at cases for sure. But I'm much more, so I'm with you about messiness and idealization in a way, but I think of those idealized bits as being part of larger models. I'm not saying let's displace them with reductions. Saying go ahead and include them, but I'm not sure they're going to end up contributing much relative to the contributions of all of these other factors like mechanisms of group identification or whatever.
Yep. Thanks. Luke?
Yeah, thanks. So I have a kind of a flat-footed question of whether an ant colony is a cognitive system. You gave us this nice definition on one of the slides. I don't remember it perfectly, but it was something like a set of persisting mechanisms which work together in overlapping pattern to produce a wide variety of intelligent behaviors. And so there's a number of bits there, and I'm like, what's going to be the trouble point for applying this to an ant colony? Will it be about whether the behaviors are intelligent, or the variety is wide enough, or the mechanisms are persisting enough? Or can maybe talk us through how we should apply the definition there?
The first, what you said is really important, that the behaviors fall into a certain category, the target exponenda. Because I think you're right, and you might have made this point to me before, that on one way of reading the definition, it's just a definition of a kind of integrated system. There's nothing particularly cognitive about it. So in this particular context, that might make matters even worse for someone who hopes to exploit that to find meaningful similarities between humans and groups, because the similarity in question in that case would only be that they're systems, not that they're cognitive systems. So it's really not going to deliver much. I think where you get the cognitive does come from the phenomena to be explained. That's right. So there's a necessary condition on something's being cognitive, that it has to take place within a cognitive system where that thing is both a system and, second condition, that accounts for certain range of phenomena. It's a system that is relationally individuated or relationally characterized. It's characterized in relation to the kind of stuff it does. Right?
And so just to be clear then, so an ant colony doesn't do the right kind of stuff. It's too simplistic in its behavior.
Well, it depends on what you consider the stuff. So the stuff is very different. I don't want to, simplistic has a kind of judgmental ring to it, and I don't necessarily want to do it.
I was just picking a word.
Okay, all right.
Whatever doesn't qualify as intelligent.
Yeah. Well, there's a sense in which it doesn't qualify because it doesn't do the things that are kind of the explananda of cognitive science. But of course, that can change as this interplay plays out between observation and theorizing and so on, and modeling. So one question would be like, is there something shared in the explananda that's of interest? That would be one way to approach it. And you'd say, well, maybe you can establish significant similarity in the kind of flexibility exhibited. So ants have, as a colony, can flexibly solve a lot of problems. I know the bee case better than the ant case, but people talk about this, the ability of bees to find new homes and how structured this is.
Democracy, yeah.
Yeah. And so one of the problems in some of these cases is that you might have some flexibility in the solving of a specific problem, but not a wide range of problems solved. So there's some concern about that. The part of what intelligence is a sort of ability to and so on. And so that might be missing. That maybe the phenomena aren't that similar in the first place. But even if you get similar phenomena, then you have to, I think you should ask the further question, is there a shared property variation in which, in both cases, accounts for variation in that shared thing, like the degree of flexibility or something like that? And so that's, what's your measure of integration? What do you think is producing flexible problem solving in one case? Does that property appear in the other case? And does variation in that property in the other case explain the same thing it explains in the first case? That's the kind of thing I'm looking for. And it's not, I don't know enough about ants to know whether they would satisfy that kind of criterion or whether that kind of research program would yield a positive answer.
Okay.
Any more questions, Luke?
I mean, do you have an off-the-cuff answer to like which animals you think are going to qualify as cognitive systems, just to kind of benchmark here? Because an ant colony is distinctive in that it's lots of organisms kind of running around separately. And if the only reason it's not a cognitive system is it's just kind of not smart enough, so to speak, in the behavior it performs, that's quite different from someone saying, well, an ant can be a cognitive system, but not a colony. I'm just sort of trying to clarify if it's the collectiveness or the relative lack of sophisticated behaviors.
Yeah, along that particular dimension, it's the latter. There's nothing. Okay. The ant wouldn't be a cognitive system either. It's a wide range of forms of problem solving. They don't have to be the same problems we solve. If the bees can do some fancy stuff to direct their conspecifics to the location of the nectar, and they can do some fancy stuff to decide, and fancy here is just a loose way of talking, but they can also solve the problem of finding a new nest when the existing one doesn't suit their purposes any longer. and then fill in the blanks, and it is pretty impressive that humans do this in a relatively open-ended way. I don't want to exaggerate. Cameron Buckner has this great term, anthrofabulation, which means like overestimating how, what kind of intelligent behavior we actually produce, or the width of the range of the intelligent behavior we produce, or how like innovative we can be, or those kinds of things. We want to be realistic about our limitations for sure. But there is a pretty wide range of problems, like sending people to the moon and curing polio and making submarines, and the list goes on and on. It does look like a much wider range of problems solved than what you see in typical animal species, whether as individuals or as groups. There are cases I know that I've gotten more attention, and I'm perfectly open-minded about dolphins and chimpanzees and this kind of stuff. But there is a kind of worry that, titles of papers don't prove anything, but long ago I wrote a paper called "Cognitive Science Isn't About Cognition." At least that was the subtitle, because I don't think cognitive science is about cognition. There's a little bit of it that's about like how to construct a universal Turing machine or something like that, or whether there are non-computable functions or something. But for the most part, cognitive science is about this particular kind of outrageous suite of things that humans do. And finding, it would be about further things if we could find things that share the breadth of that kind of problem solving, or just have the same processes on the inside. For whatever reason, they like to sit in dark rooms and they don't exhibit any of these behaviors, but they have the same structures. That would be okay too. But again, it's not that they behave the same way we do, but the breadth of the problem solving and that kind of thing is important. So I don't have anything against science fiction cases. If you can come up with these, I just think that's not what cognitive science studies. So, yeah.
So yeah, if I could follow up on this, since the other people don't have their hands up, that seems like a very conservative view of what entities have cognition, because Luke's cat, I guess, just jumped up, and it's not going to put anybody on the moon or fund a college education or anything like that.
Yeah.
You said you were open-minded about apes and dolphins, which sounds like you're not totally convinced that apes and dolphins have cognition. I just wondering how restrictive you really want to be here. Of course, with other vertebrates, they're highly homologous, brain areas, right? So you could say, okay, go for homologous brain areas, that's enough, right? And then you've got a natural kind, maybe you want to go that way. But it didn't seem like you were going that way. It seemed like you were going more for the distinctively human kind of stuff. So I'm just kind of curious, how restrictive do you want to be here?
Yeah, so it depends on what the question is. Restrictive in the application of cognition, I'm open to pragmatic arguments. It's sort of like, I don't know, I'm sure Edouard Mechery's line about concepts, and at least some of the time what he seems to be saying is like, concepts aren't a natural kind, but there can be some use for the term concept as a nominal kind, maybe for organizing conferences or for creating panels of funding bodies or something like that. The example I used to give is, I went to the ICOM, International Conference on Memory, which is held every 4 years. And it's massive, 5 days of talk after talk on this kind of aspect of memory and that aspect of memory. I was going to say nobody talked about memory simpliciter, maybe in one of the presidential addresses, but I think I would say nobody talked about memory. And so what's the function of that word in the title, the International Conference on Memory? It's purely organizational. So, fine, like that, or it refers to some loose way of grouping observed phenomena together, but with the acknowledgement that genuine kinds, scientific kinds, are not observational kinds. They're causal explanatory kinds. And so my line about the chimps or the dolphins or gorillas or whatever would be like, they might have like really super fascinating, interesting processes going on. This isn't a value judgment. It's just not the same kind as what's going on. in our case. And so I think I find this topic very hard to talk about because many people, I think, have interwoven these two questions. Like, you have to treat my cat well because my cat cognizes. And I'm like, no, treat the cat well anyway, but it doesn't cognize as far as I can tell. That's like, maybe it has some valuable, we haven't been talking about phenomenal states. Maybe it has some experiences that have value properties. The ethical questions related to phenomenal consciousness are deep and that kind of stuff. But it partly reflects the distinction I'm trying to make, is that I'm not addressing those questions because I'm really not interested in whether the other systems are valuable or not, or whether we should treat them with respect or not. It's just not, it's not part of the case. It makes for really good TV, for Jane Goodall and so on, David Attenborough to come on and talk about how, smart these animals are, but I just don't know whether the philosophy of science is going to give us shared kinds, and I'm inclined to think not. At least I'd like to know what, what would we be saying about these cases if we didn't have all these kind of sympathies with animals and concerns about respect for animals, and if we were just saying, like, hey, here are two trees. Do they share any interesting kinds? Right? Two plants to be, broad. There's a spindly little plant here, and here's this stiff, big oak tree over here. What, do they share a kind or not? And it might be that the only kind they share is so far back, it's some interesting evolutionary property maybe, but beyond that, it does no causal explanatory work with respect to most of the questions biologists ask about plants. And so you'd say, well, maybe they share something, but it's super thin.
So now I want to take your view and loop it back around in a full circle, right? Okay. So here I'm going to be Rupert asterisk and say, okay, memory isn't a natural kind. Cognition isn't a natural kind. There are these loose aggregations that you can use as subheadings for subdisciplines or something like that. And now we're not constrained by explanatory unity anymore, so we can go ahead and say that and ants and ant colonies have cognition, because it's not about natural kinds anymore.
Sure, absolutely, yeah, absolutely. Because what I'd say is that the kinds in memory, the natural kinds are more likely to be the more specific things like face recognition, memory, the ability to recognize faces, to re-identify faces, navigational skills, the kind of encoding of information relevant to those things. And so those would be maybe genuine kinds, and you might find out that the other subjects you're interested in, groups or animals or whatever, don't have those things, or do, which as the case may be. And so we might share natural kinds with them or natural properties, or we might not. But if cognition or memory or whatever, any of these terms become, I would say the same thing about consciousness. If these become just these kind of like umbrella organizational terms, then it's more of a social question. Like, if the same people who are interested in studying human behavior on an n-back task are also interested in seeing whether jays can find food when they're approach the cache from a different direction than when they cache the food, then we can have a conference on memory that includes jay researchers as well as cognitive psychologists studying working memory with n-back tasks. But then there wouldn't be anything particularly deep about it. It would just be like, hey, both these groups, maybe we think these groups, we have some suspicion that their analytical tools would be useful to share or something like that. Yeah.
Okay, yeah, pretty much going the realizer functionalism path, right? The ideal way to do cognitive sciences is to go in more identity inspired approach, more realizer. The proper way to be a functionalist is to be a realizer functionalist.
I think that's right. But maybe what's doing just as much work here is the the chauvinistic, for want of a better term, but that's the term Bloch used 45 years ago or whenever it was. You know, one of the questions was for psychofunctionalists, but I guess it would be for analytical functionalists as well, is kind of, but especially for psychofunctionalists, is like how to individuate the inputs and outputs, right? How fine-grained should they be, right? And if you make them fine-grained, then you wind up with a chauvinistic functionalism, because the inputs are going to have to do with things like, you know, the specific shades that are detected by trichromat, or, you know, the specific ways they're detected, maybe, you know, the activation, you know, triplets of activation values or sextuplets of activation values of opponent processing cells. And, you know, so, I mean, Bloch just kind of put this as a problem many years ago. Like, functionalists have to decide which kind of end of the spectrum they're going to lean toward. I think that for the purposes of doing the science, you see lots of chauvinism, not of the kind of species or gender-based or anything like that. I mean, just sort of push toward the more specific, but not always, because, you know, lots and lots of experimental papers have a part in reporting the results where they say, you know, we split the data into these two groups, whatever, male subjects and female subjects or something. And it turned out there was no effect of doing that. So let's just go back to the main effect for all the subjects. So, you know, it's not always a drive to the more specific way of breaking down the data, because sometimes that just doesn't give you any power or results, I mean. But in general, I think, you know, we're interested in the fine-grained, exploring the fine-grained details of stuff is often the way to find out what's really going on, to get a better beat on the process that's producing it. You want to poke it from lots of different angles, and angles are specific things. Yeah. So the science tends to be more chauvinistic than whatever Bloch put at the other end. Now I forget the term for coarse-grained roles. Yeah.
I think he might have said liberal.
Liberal, yes, that's right.
I think we can wrap up, right?
Yeah.
Thank you so much for participation in this English session. I think you won't be able to participate tomorrow, right? Because the language barrier, it probably wouldn't be very prolific for you to to engage in a Portuguese session, right? But we thank you so much for the contribution for the book, for the presentation here, and thank you. Thanks so much.
Yeah, thank you so much for this event.
Thanks, Sophie and Eric. Wonderful paper.
Yeah.
Great
Bye.
paper.
Sorry I couldn't come to the first part.